Hello, in this video, we want to talk about unit normal vector. In our last video, we discussed what? The concept of grad of a particular surface. So now, before we go on, when is a vector said to be a unit vector? A vector is said to be a unit vector if the modulus of that vector is equal to 1. Like, for example, if I have a vector R, okay, it's said to be a unit vector if what? The modulus of R is equals to 1. Now, but in this question, we want to deal with, or in this video, we shall be talking about unit normal vector. That is, a vector is said to be unit normal if we have, let's say R is a vector now, the R, is divided by the modulus of R. So this vector is said to be what? It's said to be unit normal. That is the vector R all over the modulus of R. Okay? Now, how do we now solve this problem? How do we solve this problem? Let's look at how this problem will solve. Let us define the surface using the parameter phi. Let the surface phi, the surface is given what? X squared yz plus 2xz squared minus 4. So that's the surface. Good. And the point on the surface, let's point on the surface, point P on the surface be what? 2, minus 1, and 3. Good. Now, how do you now find the unit vector that is normal to the surface? Now, let's clean this. Let's clean this. How do we do that? Let's clean this. Now, recall our grad, is what? I, the del x plus, j del y plus k del over del z. That is grad. Well, grad phi will just be I the phi all over the x. That is del I del phi the x plus j del phi del y plus k del phi del z. Okay. Now with that, let's write the question somewhere so that when we need the question, we'll not have a problem. So the 2, minus 1, and 3. That's the point. Okay. And the surface is defined as x squared yz plus 2xz squared minus 4. Because we may need it when we clean it. X squared yz plus 2xz squared minus 4. Beautiful. Now, what next do we now do? We just want to find, like I said in the formula, the vector, the unit vector normal to the surface is calculated using the component vector all over the modulus of that particular vector. Okay, so in this case now, what we actually want to find is what? We want to find the grad phi all over the what? The modulus of grad phi. That is exactly what we want to find at the point 2, minus 1 and 3. So now let's go. Let's find the grad phi. So the grad phi now, will be I, that is del dx of our phi. Our phi is x squared yz plus 2x z squared minus 4 plus j. Okay, I hope you are following. Del dy of, again, our phi, x squared yz plus 2xz squared minus 4 plus k del dz of what? X squared yz plus 2xz squared minus 4. Okay, now let's do that. Let's evaluate that. Okay, now we have I. Now we want to differentiate partially with respect to x. So differentiating this with respect to I have 2x multiplied by y and z, yz. Okay, beautiful. Plus, if you differentiate x here, it is 1. 1 times 2. 2 times z squared. That's 2z squared This is constant. It will be 0. Good. Now plus j. I hope you are following. Now with respect to y now, y will be 1 here because y raised power 1. So it will be 1. When you differentiate y here, multiply the remaining one with x squared z. That is x squared z. Then plus any y again, no. So every other thing here will be 0 because there's no y there again. Then plus k, plus k, with respect to z now, this is 1. When you differentiate this, is 1. 1 times x squared y, plus any z again, yes, z squared. So the 2 here will come here, 4xz. 4xz. Good. Good. Now, having done this, the next is now what? Is to apply, because this is just, what we have just gotten here is grad phi. But remember the question says at the point. So therefore, grad phi, at 2 minus 1, 3 is x, y, z will now be equals to what? Well, there's I, okay, 2 times x here is 2, our y is minus 1, beautiful, our z is 3, good, then plus 2, our z is 3, yes, 3 squared, good, you close that bracket for I, then plus j, our x is 2, 2 squared, multiplied by our z is 3, beautiful, that is closed, then plus k, our x is 2, 2 squared, our y is minus 1, plus what? Let me write this thing again better, x squared yz plus x squared yz plus 2xz squared minus 4, because I may need it, okay, now plus 4 x, my x is 2, beautiful, then multiply by z is 3, beautiful, okay, so I think that is correct. Yes, let's check. Okay, y, yes, so now let's expand. We have what? I into 2 times 2, 4 times minus 1, minus 4 times 3, minus 12, minus 12, 3 raised power 2 is 9. 9 times 2, 18, plus 18, correct, plus j, 4 times 3, 12, plus k, this is minus 1 times 4, minus 4, plus 8 times, this is 24. This is 24. 8 times 3 is 24. I hope that is correct. All right. So let's continue. So we can expand and bring out this in the normal form now. Minus 12 plus 18, that's 6. 6i, so let's place it well. So I will be at the other side there. It's better that way. Then plus 12j, then minus 4 plus 24, that's 20, plus 20k. So this is what? The grad of phi at points 2, minus 1, and 3. I hope we understood this. And there's no problem in the calculation, okay? Yes, I want to believe that there's no issue in the calculation. Now, having done this, now the next thing is, which is the final step, is to find the unit normal. So the unit normal, let's n be the unit normal, vector to the surface. Okay, that is n is equal to the grad phi all over the what? The modulus of the grad phi, which is, now let's find the modulus of the grad phi first, so that we just place everything there. Okay, let me write this one somewhere. So I will need it, 6i plus 12j plus 20k. So this is the formula we want to apply. Let us find what? The 2 minus 1, 3. 2 minus 1, 3. So that's now I want to find the what? want to find the modulus. Now the modulus of grad phi is what? The square root of, now our x, 6i is xi. So this is a component of the vector. This is 6 squared plus 12 squared, good, for y, plus 20 squared. So that will give us what? 36 plus 144 plus 400. And that will give us what? This is 36 plus 144. That's 180. 180 plus 400. I think that is 580. That is 580. I hope we are following. I hope that is correct. Now, let's see. 580. That is the square root of 580. Root 580. Okay. Now, can we get the square root of 580 easily? Will that be possible? Let's check. If 580 will be 58 times 10, can we split it in such a way that there's this 2 in 58? That's 29 times 2 times 10. Okay, that means 29 times 20. Good. So if we want to split this, we can have it 29 times 4 times 5. So that will be 29 times 5 times 4. Okay. That will give us, we are looking for a way by which we can easily get the rational sort from that. So this 58 now, 580 now, can be said to be root 29 times 5. This is 45, 145. This is 145. This will be what? Root 145 times 4. And unfortunately 5 does not go there. Okay. If 5 goes, we cannot get the rational value of 5. So that is the best way by which we can express that. That's the best way. Okay. Now, this is the same thing as what? 2 root, because the square root of 4 is 2 root 145. So we have gotten the what? The modulus of grad phi. Therefore, n, which is what? Grad phi all over what? Modulus of grad phi will now be equal to what? Our grad phi was what? 6i plus 12j plus 20k. Then everything all over grad phi now, that is the modulus of grad phi, which we got now, is what? 2 root 145. So which will be, now this 2 root 145 is for all of them. Now write 6 all over 2 root 145 I, it belongs to, you use it to divide each of them, plus 12 over 2 root 145 j, then plus 20 over 2 root 145 k. Okay. Now final. The final answer will now be, can 2 divide here? 2 here, 1, 2 here, 3. 2 here, 1, 2 here, 6. 2 here, 1, 2 here, 10. So now what? I have what? Now final. The final answer is, that is, our n will now be equal to 3 all over root 145 I plus 6 all over root 145 j plus 10 all over root 145 k. So if you are watching this video for the first time and you enjoyed this video, don't hesitate to subscribe to this video channel. Click the notification bell so that each time I upload a video, you'll be duly notified. And if you have been our ardent subscribers and you enjoyed this video, comment, share, and like. God bless you. Bye.